But now let me introduce Martyn Tulloch, who heads up the energy integration part of the OGTC, to deliver a presentation which brings the integrated energy vision to life. Martyn, over to you.
Thank you very much, Andrew, and good morning, everyone. This is the first major piece of analysis that OGTC has published in partnership with the Offshore Renewable Energy Catapult. Now, it was, of course, a team effort, and there are too many individuals and organisations to mention personally. But right at the outset, I'd like to briefly thank my colleague Jason Patterson, who has led this project and has been living and breathing it for most of 2020. As Andrew mentioned, it's perfect timing that we're discussing this on the same day as the Climate Change Committee published their 6th carbon budget, because this report presents a reimagined North Sea. It showcases the integrated net zero energy systems that's going to be essential if we are to deliver the commitments of the Paris Agreement. And also it highlights the fantastic business opportunity that this could provide. Most importantly to me, it demonstrates the transformational impact this could have in communities across the UK, with thousands of new jobs and new high quality jobs potentially being created. Now, if we look at the structure of today's presentation, we're going to start with a brief overview of the UK's resources. We'll then look at the world that we have today and what we need to do to get to the net zero world we want to in the future. We'll take a look at some alternative scenarios for a net zero North Sea. We'll close by looking at the size of the prize, and if we have time, I may even bore you with an explanation on the methodology behind the numbers. Now, there are 3 crucial messages I want you to take away today, so I'm going to be quite blunt and mention them up front. They are that, number 1, the UK has got an opportunity, quite a unique opportunity, to become a supplier of energy rather than an importer. And number 2, if we invest decisively and astutely now, we can become a world leader in the development and export of net zero energy technologies. And finally, as I mentioned before, we can create thousands of jobs and deliver benefits to communities across the UK. So let's start with a look at what's in play in our resource base. We highlight in the report that the 4 nations of the United Kingdom must deliver as much of our energy demand as possible from indigenous sources, not just in the North Sea, but across the country onshore as well. So let's start by taking a look at those resources. It's important to stress that this is not what we see being deployed, it's merely the realistic potential. We'll cover deployment scenarios later on in the presentation. Wind Europe published a seminal report in late 2019, and it highlighted that the UK has got 40% of Europe's low-cost wind potential. We see that as being up to 250 gigawatts of deployable potential realistically. It ties in with the Committee on Climate Change's balanced pathway, which sees between 60 and 125 deployed. If you look at wave and tidal, wave and tidal has long been understood as quite a unique British resource. I grew up in Orkney. I spent many summers going to and fro across the Pentland Firth, probably the best tidal resource in the world. And it's estimated that the UK could have access to half of Europe's marine and tidal potential, with a wave resource estimated at 32 gigawatts, a tidal stream resource of a similar figure, 32 gigawatts. If you add in tidal range of 50 gigawatts, it's clearly got huge potential. But it's important to stress that technology in this field is in its infancy, and there's a clear opportunity to develop a lead, but it's going to take a concerted effort. One other thing to mention is that tidal power, of course, is predictable and could play an important role as baseload power. Now, solar is not something that you immediately associate with the UK, but we do have 13 gigawatts of installed capacity, producing roughly 13 terawatt hours per year. So a capacity figure of around about 11–12%. The UK has got lower solar than the most of Europe, but interestingly, our colder climate and cooler winds actually cool the panels and raise efficiency. Now, the Committee on Climate Change estimates that the UK could install between 145 and 615 gigawatts of solar power by 2050, and we use the lower range estimate here. In oil and gas, we still have significant oil and gas reserves, some 5.5 billion barrels of oil equivalent of proven reserves. If you add in yet to find, the OGA's latest estimates put remaining resource in the range of 10 to 20 billion barrels of oil. It's going to be essential that we produce this in a net zero manner with zero operational emissions. And earlier this year, the OG UK published the industry's first roadmap with a clear trajectory to net zero. in 2050. We've also got interim targets of a 50% reduction by 2030 and a 90% reduction by 2040. Now, electrification and integration of renewables into offshore operations is going to be essential to get to this target. Also, new technologies such as using alternative fuels and potentially capturing carbon offshore will have a key role to play. In hydrogen, we've got fantastic opportunity in the UK to develop both blue and green hydrogen. We see a range of scenarios here. We see blue potentially playing up to 270 terawatt hours, and 270 terawatt hours per year is what the Committee on Climate Change's further ambition scenario indicates that we need as a country in 2050. Now, it's going to be a mix of green and blue, and we present various options in this report. We'd love to see offshore wind and green hydrogen play a much higher role than it currently does in most base case projections today. But alongside blue hydrogen, we need carbon capture and storage capacity. So if you look at the numbers here, they're quite mind-boggling. 78 billion megatons of storage capacity in the UKCS versus 364 million tons per year of emissions. So that's roughly 214 years of storage capacity for our own carbon footprint. But we really have enough capacity there to import significant quantities of carbon from Europe. Now, CCS is a crucial component of industrial decarbonisation. It could open the door to the UK becoming a world leader in that sector. And also, as I mentioned, it could open the door to import opportunities and helping Europe decarbonise. Europe has basically got 10 times the carbon footprint of the UK, 10 times the energy demand, 10 times the market potential. So moving on to take a look at the world that we have today versus the world that we need to get to in 2050. If you look at the UK's electricity production today, it's roughly 300 terawatt hours. Now, electricity generation in the UK has seen a rapid decarbonisation in the past decade, primarily due to the phasing out of coal-fired power stations. 54% of the UK's electricity generation currently comes from low carbon sources, including 37% from renewables, 20% from wind alone. It's important to also highlight the balancing role that gas power plays today, and indeed will continue to play even in 2050. In 2050, we need to electrify the heck out of everything, really. It's going to be a huge effort to electrify transport and home heating and various industrial processes. So we'll see a more than doubling of the electrification of the electricity generated in 2050. It's interesting, this morning I heard Chris Stark being interviewed on the radio, and as has happened many times before, the interviewer took a look at the app that shows you the UK's current electricity mix. At that point in time, there's hardly any wind. It was quite a calm morning today, so wind was producing 9%, nuclear 20%, and gas and coal 60%. Gas will continue to have an important role in 2050, but it'll have to be clean gas. So either gas combined with carbon capture and storage, or potentially using a low carbon fuel in the front end of the gas turbine. Now, in terms of the total energy demand, at the moment, the UK has got a total demand of 1,663 terawatt hours to be exact. That will decrease slightly due primarily to efficiency savings in 2050, but we still have a huge demand as a country. Roughly 40% of our energy demand today comes from oil, roughly 40% from gas. As I mentioned before, gas is predicted to play a key role in that energy transition. Oil will, of course, decline over the next 3 decades. And the world that we want to get to, the further ambition scenario of the Committee on Climate Change, is what we base a lot of our analysis around. It targets that reduction in oil demand primarily as a result of electrification of transport and domestic heating. And there'll be a huge increase in renewables to meet the increased electricity that I mentioned. And we'll also need at least 270 terawatt hours of low carbon hydrogen. So let's move on to look at our 3 scenarios that we present in the Integrated Energy Vision. We've termed these 3 scenarios emerging, progressive, and transformational. They've been selected to illustrate a range of options to 2050, and they build on that further ambition scenario of the Committee on Climate Change. Emerging is built around a significant contribution from gas and blue hydrogen, with wind and carbon capture and storage playing a supporting role. Moving on to progressive, the energy mix also features gas, but it sees a much larger role for green hydrogen and offshore wind. And under the transformational scenario, green hydrogen and wind take a leading role with reduced contribution from gas and lower requirements for carbon capture and storage. The potential upsides are clear, up to 232,000 direct and indirect jobs, total economic impact of 125 billion, and a potential cumulative investment between now and 2050 of 416 billion, depending on which path that we choose. Now, this graphic here is one of my favourites. It's my absolute favourite from the report. It takes a bit of time to get your head around it, but just the quality and the clarity of the information stand out to me. So hats off to the team that produced this. Maybe starting with where we are today in purple, today in 2020. So at the moment, we've got an energy system in the North Sea that supports £40 billion of economic impact. 140,000 direct and indirect jobs. If you look at the share of imports, it's 45% at the moment. We've invested on average £10 billion per year in capex over the last 3 decades in the North Sea. We currently generate 32 terawatt hours of wind from an installed base of roughly 10 gigawatts, 27 terawatt hours of grey hydrogen, all for industrial processes. If you look at oil and gas, we're currently importing roughly 40% of our oil and gas needs. We're producing 640 terawatt hours of oil, 700 terawatt hours of gas, and we're storing no carbon dioxide. Now, in the emerging scenario, which is the one closest to the further ambition scenario of the Committee on Climate Change, we envisage 60 gigawatts of offshore wind, so that's roughly 4,000 turbines at 15 megawatts apiece, plus an increase in onshore wind and solar. Renewable energy or renewable electricity plays an increasing role, but gas is still a significant contributor, alongside a requirement for carbon capture and storage of 140 megatons per year. Total energy production remains heavily reliant on hydrocarbons in this scenario, primarily gas, which would require significant imports. You can see in the emerging scenario, we're still sitting at 81% or increasing to 81% of imports, so we're heavily reliant on gas from other parts of the world. It would also see a significant increase in blue hydrogen production, with some 60 plants required across the UK and a total installed capacity of just over 35 gigawatts. In progressive, the one to the right of emerging, we see an increased share of offshore renewables, alongside a blue-green hydrogen split that's more equitable. We'll see 100 gigawatts of offshore wind installed, 73% blue hydrogen, 27% green. We'd still be producing all of the UK's oil demand from our own indigenous resources, but we'd be reducing the reliance on imports, reducing that down to 72% from 81 in the emerging scenario. And this is the one where we really start to make an economic impact. Total economic impact across the UK is boosted from 40 billion in 2020 to 100 billion in 2050 in this scenario. And employment actually increases from 140,000 direct and indirect jobs to 158,000. Also, the more balanced energy system of progressive, with a higher proportion of offshore wind, will drive innovation in blue hydrogen and carbon capture and storage technologies. Now, the final scenario here, transformational, is the one that, in my opinion, we really should be aiming for as a country. It's an energy system that's basically driven by offshore wind and green hydrogen. Under this scenario, we reduce the reliance on gas power for generation. It's phased out in the early 2040s, 10 years ahead of the progressive scenario. We need 150 gigawatts of offshore wind, so 10,000 15 megawatt turbines. We'd be producing 93% green hydrogen, reducing our gas imports to 54%. It's actually much smaller in absolute terms, as it's reduced from 801 terawatt hours per year in total in the emerging scenario to 333 terawatt hours in total gas in this one. We'd also see a reduced reliance on carbon capture and storage of 91 megatons per year, but it's really important to stress that this is still a substantial industrial opportunity, even at 91 megatons per year. Now, what that looks like in terms of total economic impact across the UK, we'd boost our total economic impact from £40 billion today to more than 125 billion in 2050. We'd increase employment from 140,000 jobs today to 232,000, and that is just direct and indirect jobs. We've deliberately not included the induced jobs in these estimates. We'd see huge innovation across the green hydrogen and offshore wind spheres. That could result in a capex saving of 153 billion by 2050, and I'll touch on that in slightly more detail in later slides. Now, this scenario would see renewables supplying 80% of electricity. This is beyond current day variability limits, but we see advances in battery and hydrogen storage technologies in particular, as well as smart grids and demand side management as being absolutely essential to delivering this scenario. It would require £460 billion worth of cumulative investment to 2050, a huge scale up of green hydrogen supply, and a much more efficient consenting process as well, if we're being realistic, to allow the huge scale of offshore wind deployment that we'll need in just under 30 years. Now, I'll touch on these scenarios in more depth in these slides here. But ultimately, it's kind of repeating what I've just mentioned on the previous slides. I did feel that previous slide was such a powerful way of summarizing the four scenarios. So basically, just a little more detail on emerging. I mentioned that that's got 60 gigawatts of offshore wind. We are 100% reliant on blue hydrogen in this scenario, and we're 81% dependent on the import of gas. This is the one that sees the largest carbon capture and storage sector at 140 megatons per year. Now, in progressive, as I mentioned, we see a much greater deployment of offshore wind, which leads to more green hydrogen. A reduced reliance on blue has the knock-on impact of lower amount of CO2 storage capacity required. We also mentioned on the right here that the cumulative investment of 293 billion. That's something that I personally feel that the oil and gas sector and the offshore renewable industry need to work in concert to make sure that we deliver that scale of investment. It's comparable to the scale of investment in the early 70s when we delivered the infrastructure that's underpinned the oil and gas sector over the last 4+ decades. And then transformational, you can all take a look at this in more detail in the report, which I would encourage you to download from our website. It's a very easily digestible but impactful report. In transformational, it's the one that we should be aiming for, £460 billion of cumulative investment, 150 gigawatts of offshore wind deployed, greatly reduced reliance on blue hydrogen, and a greatly reduced reliance on imports. Now, we're a technology development team in OGTC, and that is our core goal. We're here to develop and deploy the technology, the affordable technology that's going to be necessary to get to a net zero North Sea. We published a report 3 months ago, Closing the Gap, which again I would encourage everybody on this call to try and download. It's a fantastic piece of analysis that identifies technology gaps across the 4 key areas that we're focused on. So we need to make sure that we develop technology to get oil and gas operations to net zero. We also need to make sure that we develop technology to deploy the affordable offshore wind that we need to electrify the basin and to provide the green hydrogen capacity that we need in 2050. Alongside that, we need to reduce the cost of hydrogen, and we need to reduce the cost of carbon capture and storage. So net zero is achievable using existing commercially ready technologies, but not in a manner that would be considered affordable today. It's absolutely crucial that we deliver significant cost reductions across the whole suite of technologies identified here. If you look at green hydrogen, we see the potential for capex savings of 61% on the base case today's technology. So that could be £55 billion worth of savings. Green hydrogen is of course a nascent technology with limited application today, but there is a huge opportunity to both develop this increased scale of technology and dramatically reduce the costs by innovating technically. So we're looking at things like seawater electrolysis, so you remove the need to desalinate and cleanse water before you put that into the front end of the electrolysis process. We're looking at innovations in electrolyzer catalysts, as are a number of other organizations. We're looking at potentially deploying systems subsea to reduce the the capex spend and increase the efficiency. In blue hydrogen, we're looking at enhanced reactor membranes and catalysts. We're looking at alternative productions, totally new technologies that would potentially be a step change in efficiency from the technologies we have today. And we're also looking at things that would add to the total system, like can we reuse pipelines? Can we reuse gas reservoirs as interseasonal storage sites? And that sort of leads into the carbon capture and storage space. We see a reduced potential for cost reduction here. It's a more mature technology, but our analysis does predict that we could see a 13% capex saving, which could be 1.3 billion over the next 3 decades. So in carbon capture and storage, we're looking at things like modeling geological behavior. How can we get better at that? How can we adapt techniques from the oil and gas industry and deploy them in this new industrial sector? We're looking at developing modular retrofittable solutions, things that could be deployed offshore, but equally could be deployed at onshore industrial sites. We're looking at direct air capture and seawater capture technologies as well. So to get to net zero, we don't have to get to gross zero. We need to make sure we get to a net zero carbon emissions. And if we look at most commonly accepted scenarios for getting to net zero, they all include some degree of negative emissions technology and indeed natural carbon sequestration. So both areas that we're developing technologies in partnership with a number of other organizations, both in the UK and across the globe. We're looking at what can we do to repurpose existing whales to make them compatible with carbon storage, reservoirs likewise. And I think equally importantly, what can we do with the skill set that we have in oil and gas, especially the subsurface and geological professionals? Can we make sure that they're able to transform that skill set and transfer into a new growth sector? In offshore wind, both fixed and floating will have a role to play in the UK. And if we're to meet that ambitious 2050 target, we see the potential for capex savings of roughly 24%, which could be £97 billion worth of savings over the 30-year period. Now, there are finite options for fixed bottom wind in the UK. So we're looking at developing a UKCS specific floating wind technology, something that's designed for our unique water depths and met conditions and indeed soil conditions. The cost reductions in offshore wind will be increased by increasing the capacity of turbines, and as more focus is placed on the floating opportunity, we see great opportunity to transfer technology from oil and gas into the offshore wind sector, into the floating wind sector in particular. So things like innovative mooring solutions and potentially innovative foundations as well. So at the moment, we're working with a local Aberdeen-based company that's got a tension leg buoy solution that could reduce the cost of floating wind by potentially 10 to 15%. In oil and gas, we need to make sure that we develop cost-effective technologies that allow us to produce oil and gas at a net zero carbon footprint. So electrification will have a really important role to play here, but also there's other solutions like low carbon fueled gas turbines, potentially modular carbon capture and storage. And we're looking at the whole suite of technologies from production through transport to end use to make sure that we've got a system that works offshore and crucially is safe for the people that have to live and work on our offshore assets. Now, I'm almost at the end of the presentation, and this slide here summarizes the 3 scenarios: emerging, progressive, and transformational. And I really just want to reiterate that key message that I outlined at the outset in the presentation. We've got a huge opportunity here as a country to become a supplier rather than an importer of energy. If we look at the potential to export green hydrogen to Europe in particular, that is something that's going to be absolutely crucial to Europe's ability to get to net zero in 2050. The European energy policy, the Green Deal, is built around a huge increase in green hydrogen production from offshore wind in the north of Europe, from solar power in the south of Europe and North Africa. And numerous organizations across Europe are actively engaged at the moment in negotiations with suppliers across the globe. So there really is a unique opportunity for the UK to take a lead at this crucial stage. I've talked through these numbers before, so I don't want to really labour the point here. You can read them for yourselves, but just a few key points. Today, we've got an energy system in the North Sea with a total economic impact of £40 billion per year. Even in the emergent scenario, our most conservative scenario, we've got more than double that economic impact. We've got a slightly reduced number of jobs due to the decreased intensity of employment in offshore wind compared to oil and gas. But the real prize for me, as I mentioned before, is the transformational scenario. We really need to do everything that we can to make sure we get to this scenario. We've got a huge potential benefit there in terms of jobs, and high quality jobs as well in new manufacturing industries and operational sectors across both oil and gas, offshore wind, carbon capture and storage, and blue and green hydrogen production. And that leads on to this second last slide here today, where you see a feel for the mix and the share of jobs. So at the moment, employment in the North Sea is dominated by the oil and gas sector, as it has been for the last 4 decades. It's provided countless high-quality jobs to communities across the UK, from Shetland in the north all the way down to Cornwall in the south. I'm sure we've all enjoyed the benefits of that the sector has brought us, but that sector will decline. We know that we're a mature basin, but even in a net zero UK in 2050, we'll still need all the oil and gas that we can produce from our own basin. So it's absolutely pivotal that we do everything we can to produce that in as low a carbon fashion as possible. But alongside that, I hope this slide here illustrates the sort of mix of jobs across the various sectors. So offshore wind is going to be crucial in all 3 scenarios. What we really need to try and make sure happens is that we increase the amount of green hydrogen in the mix and reduce the reliance on gas imports. And to do that, we really need to drive down the price point. We have to innovate in the technologies, both the electrolyzers and the floating and fixed wind technology, to reduce the cost of the electricity that feeds into the process, but also to reduce the cost of the process itself, and produce green hydrogen at a cost comparable with blue hydrogen technology in 2050. Now, I think I've got a couple of minutes to bore you with the methodology. So I'm sure this will be something that you'll have questions around. I really need to pay tribute to our colleagues in Offshore Renewable Energy Catapult, who undertook the vast bulk of the work here. They've got a really strong economic modelling team, and we took quite a straightforward approach to economic impact. We looked at the revenue, the capex, the opex, the decommissioning costs across the sort of 4 areas and the scenarios that we developed. So oil and gas, offshore wind, hydrogen, and carbon capture and storage. We then assigned standard industry codes to those, which gave us revenue distribution and sort of a share of capex in construction, for example. We adopted, using our own sort of best estimates, a UK content share of between 40 and 75%, depending on the sector and depending on the metrics adopted. And we did assume an increasing share of UK content as these industries matured, and that's something that I know is integral to the offshore wind sector deal, but it's something we really need to focus on in the other sectors as well. Then ultimately we multiplied that economic impact multiplier and summed it up to calculate the total impact. In terms of the jobs, it was a similar approach. We looked at the estimated percentage paid for labour. We looked at the UK share of spend on labour depending on the UK content, and as anybody that's been involved in estimating a fabrication job or an engineering project would know, it's roughly between 25 and 30% of your total cost is typically labour. So we adopted 25% as a conservative assumption here. Looking across the sectors, we adopted an average annual payroll cost of 50 to 65k depending on the sector. And then we simply divided the UK share of labour by the average payroll cost. Cost savings, again, we adopted quite conservative learning rates for the capex cost savings. And crucially, they're all dependent on significant technology advancements and developments, which ultimately is what OGTC and ORE Catapult are all about. And that's going to be the real focus for both organisations over the next decade and beyond. So I've said all that I want to say. I will hand back over to you, Andrew, and hopefully you can facilitate quite an informative and engaging Q&A session.
Martyn, thank you very much. That's an excellent overview of what is a very detailed report, but lots of interesting things for us to explore during the course of the conversation. I'm first of all going to bring in our panelists, Colette Cohen, Chief Exec of OGTC, and Andrew Jamieson, who is the Chief Executive of ORE Catapult. Guys, if you want to come off mute and video, that would be great.
And my control, I think I'm waiting for Hannah to take my off video.
No problem. Well, let me come to Andrew first. Andrew, obviously you've been closely involved with the development of this report. Your team has been working alongside colleagues in OGTC. Where do you think we go from here? What happens next, do you think?
Thanks, Andrew. And let me pay compliments to Martyn for an absolutely first-class overview of a very detailed report. Superb job, Martyn. Thank you very much. Very good question, Andrew. Colette and I are very firmly of the view this report should start a conversation amongst all key stakeholders and participants. It's quite clear there are strong synergies to be created and reached between the oil and gas sector and the offshore renewable energy sector. But quite often, historically, we've been rather siloed. One industry over here, long history, new emerging thing over here, both in the sea, rather different market conditions, rather different cultures and risk appetites, etc. So what I would like to see, to answer your question, is to pull the two sectors closer together, which is much easier said than done. But so to do that, it's really to try and focus on what are the key barriers towards bringing the two sectors together. A lot of that can be around the policy measures, de-risking measures, and all sorts of things that can come into play, not necessarily massive investment, to be clear, but things that can be done to improve investor confidence in both camps. And so a lot of that has to be policy aspects of things. And as I say, creating the conversation towards where we want to see things move in decarbonising oil and gas and promoting the growth of offshore renewables and the complementarities that sit therein. And what I would like to see is large-scale projects coming together to show market participants and ultimately the investors and the stakeholders that stand behind them, whether that's government or financiers, to show, yeah, these technologies will work. Yes, there is a future for doing it more. So it's building the market confidence, Andrew, is the start of our journey, I think is what this report is suggesting.
Andrew, thank you. Colette, let me bring you in. You've talked at length about the pace needed to make this happen, and that's certainly laid out in what Chris Stark and the CCC have said this morning. How do we get that, I don't know, urgency into the conversation?
I think that's been one of our real challenges. It's a really good challenge and question. And you actually see just a lot of policies and a lot of discussions, you know, whether it's around Brexit, you know, what are we going to look like as a nation? We've got the road to Glasgow next year with COP26. So I think there is imperative right now. We have to decide what we're going to look like. The new sixth carbon budget being released today, you know, tied into the Green Deal, which was announced a few weeks ago, and reports like the one we're talking about now, all need to be used to create that momentum, create that opportunity that says, okay, we have these great aspirations. We have some visions of what it looks like. We have, whether we call them pathways or scenarios, but you know, in fact, there's quite a lot of similarity in the scenarios that you see in the CCC budget and what we've put forward here. And what it really reflects, I think, is, you know, addresses Andrew's commentary of actually we all need to work together. This is something about a behavioral change as well that's going to be required, not just from society and how we use things, but also about how we approach the challenges, not in a siloed way, but as a combined nation. So I think first we need that imperative laid out of this is what we want to look like. This is the sort of commitment we're going to deliver. And then we can sort of, in just industrial sectors like ours, will have clarity of what they need to invest in to deliver that.
It makes sense. Thank you, Colette. And I guess the other question that maybe people are thinking, and we'll see this come through, I'm sure, in this morning's conversation, is who's paying? Where is this investment coming from? How do we present what you're describing in this report as an investable proposition to those providing capital to actually make this happen over the next few decades? Colette, first of all, and then Andrew, how do you see that conversation unfolding around the investment required?
Well, it's interesting because we're already paying. Industry is investing every year, and next one, Andrew will probably refer to it, but we're already, even the sort of energy companies that are sort of diversifying into renewables are paying huge amounts to develop the next generation of wind farms and looking at new technology. It is the one area where we as a technology organization also see continuous investment is in that transition to a net zero and the technology that's required. So I think there is private sector investment. I think the part that we need to clarify is that there's the market, the end to end. We can create generation, but you want to make sure that there's actually going to be a market for it. If you think about the clarity we have around electric vehicles, we know that that's what the UK wants to go to. So there, that will be fully created, and the CCC has a high expectation of 97% electric vehicles by 2035. So ultimately, that drives a market. The market responds to that. I think we need the same thing when it comes to carbon sequestration, when it comes to hydrogen, and that would allow industry to invest in it. There are billions already being spent. So I think where we need a little bit of government incentive is in clearing up the regulations, is improving the synergies of being able to work together. And I'll stop because that's my dog.
We'll bring in Andrew now with that impromptu dog.
There's great risk my dog starts barking as well, which is why I went on mute, because he was throwing himself at the door with the postman a second ago. Colette's answered the question, I think, extremely fully, and I can only echo what's there. Everybody wants to see the bulk of the investment come from the private sector, because it should be an ongoing opportunity for businesses to be gaining and for us to be driving the economy rather than us becoming a drain on public sector finance. No one's really interested in that as the prime solution. But clearly, different markets have currently got different incentives as to where they're going and why they're doing things. And I take a very high level view. We've got net zero challenges in front of us that everybody's talking about, big numbers, climate change committee, ourselves, etc., etc. Ambition's one thing. It's got to translate into real action. And the fact that action could be defined as being relatively slow given the scale of the challenge in front, and that's being very unfair because there's a lot going on. We recognise that, but we've got to ask ourselves the question: why isn't the private sector moving so boldly right now when the ambition is clearly there? And that to me comes down to they have uncertainties as to, is this actually going to translate? Is somebody going to change their mind and we're doing something differently? So I think that's where, and Colette said, we all need to be working together. We need to be improving the investor confidence landscape. And that for me means financiers who are actually doing the projects. And it also means public sector stakeholders so that they are solid in what they're looking for and they can advise and excite the market likewise. And we all push in a singular direction. That's very difficult, but it's the kind of thing we need to be starting to challenge ourselves and addressing more readily if net zero is to come.
Thank you, Andrew. I think this report provides the platform just to do that. Martyn, can I bring you back in for a second? You are looking after the energy integration aspects of OGTC's work. So you're clearly trying to bring these various industries and sectors together. Is the appetite there now more than it has been in the past?
I think absolutely, Andrew. If you look at our own sort of operator base in the UK, pretty much all of them are looking at the opportunities that the energy transition will provide. So they're actively looking at floating wind and fixed wind. They're looking at blue and green hydrogen. A number of them are looking at carbon storage opportunities as well. So in the last 18 months, there's been a huge change in the appetite and just the understanding of the scale of the opportunity here. So I think totally that the sector is on board.
Excellent, thank you. I'm going to start bringing in some of the questions that are coming through from our participants, our audience this morning in the Q&A. So first up was David Wilkinson. So if we can take David off mute, I think you had a question around the economic impact. David, do you want to go ahead?
Yeah, first of all, I'd like to thank Martyn for an excellent presentation. My question is really, does total economic impact mean value up to 2050? I was a bit unsure what it meant.
Thanks, David. No, again, I'm an engineer, and it was something that was a bit of and it's just a different sector for me getting involved in the economic analysis. But what we've tried to do here is, as you say, we're trying to provide a sense of the economic impact across the revenue spend, the jobs, the OPEX, the CAPEX. So it's just to try and quite simply provide a sense of what this could mean to the country. So again, it all depends on the percentage of local content. That's absolutely crucial. So if we're deploying all this capital expenditure, if we can build a lot of that in the UK, that's going to have more impact across the country than it will if we import it. So it's trying to give a sense of the total value added, would maybe be another term to the country. If you look at the European Green Deal, for example, a lot of that is predicated around building electrolyzers and offshore wind plant in Europe, deploying them in the North Sea or Southern Europe if it's solar power, and then the sort of the reduction in imports and the increased jobs. So it's a very similar approach to what's been adopted in the European Green Deal, and quite simple. I think deliberately simple. We wanted it to be clear to anyone who looks at it that it's quite defendable. It's relatively conservative as well. I think there's an upside here. For example, we haven't looked at the opportunity to export hydrogen to Europe as part of this study. So that is a potential doubling. The numbers start actually to get a bit silly if you add in the export opportunity. So deliberately conservative, but deliberately simple as well, and trying to give a sense of the potential impact in a way that's tangible for the lay reader. I don't know if you've got anything to add, Andrew or Colette.
All good. Does that answer your question, David?
Well, so as well as an environmental benefit, you're saying there's a large positive economic benefit. So it's a good way to make money then.
Absolutely, it's a huge opportunity. It's a once in a generation, a once in a century opportunity for us.
Maybe I'd like to add to that. It's a great opportunity if we step in to create the jobs, the manufacturing. If we, however, decide that we're going to deliver our carbon emission reduction by buying that service from other nations, then it's not. And that's what we're trying to highlight in this report. The the positive economic impact for the country is delivered if you create the technical capability to design, manufacture, engineer, and install here. But if you choose to deliver your carbon emission reduction by buying that from somewhere else, it will cost you nearly as much, but you will not generate the positive economic impact other than the environmental positive impact of reducing your emissions. So what we're trying to raise here from a technology sort of leaning in perspective is, if you get involved now at the very early stage of this transition to a new energy future, then we can actually be a buyer and a supplier to others. And that's a massive economic opportunity for the UK.
Thank you. That sounds good.
Thank you, David. Thanks for your question. We've got 2 or 3 more coming in just now. Next up is Douglas Spalding. Douglas, if we can bring you off mute, you've got a question about green hydrogen.
Yes, I thought it was an excellent presentation from Martyn.
Douglas, you're a little bit quiet. If you could just maybe move closer to the mic or turn yourself up a wee bit.
Okay. Does that help?
I think it's a bit clearer now. Thank you.
Right. If green hydrogen is crucial to offshore wind growth, what do the panel see is required to deliver tangible, joined-up thinking, policy, and results?
Thank you, Douglas. Let's come to Andrew first on that, and then Martyn.
Yeah.
Andrew.
Hi, Douglas. So thanks for the question. So I think worth just spending a little bit of time thinking about the context. So offshore wind has clearly been a success in terms of growth rates and cost reductions that participants have achieved over a fairly short time frame. But in essence, the industry is highly competitive across each other. They have to be. They spend hundreds of millions of pounds to develop their projects through what could be argued as a relatively uncertain planning cycle. So there's a lot of money invested at risk over quite a considerable time frame. And even once they get planning permission, they've then got to compete for a contract for difference that secures the funding of the project into the longer term. So it's a highly competitive and highly focused market on doing that. In other words, they've got a lot on their plate just to deliver their own needs for offshore wind. When we then add into, but couldn't you also do the green hydrogen thing? I have to say, from the industry's perspective, they can all see the opportunity, but they have so much commercial and competitive pressure in front of them right now. That weight just lands on their shoulders as the big thing they want to get over. And UK government and indeed Scottish government are also pressuring the industry. What are you doing about jobs? Because there's one thing about putting the capacity in the water. Question is, what is UK PLC and Scotland PLC making that goes into the supply chain? So there's huge pressure on the offshore wind sector to keep delivering capacity, but also to provide, to the previous correspondence questions, economic growth that's tangible, and all of that is good, and that's the kind of things that we are highly focused on. That's what we all need to achieve. So we should also not forget the success of moving from thermal-based generation, as in coal and gas, to renewables has been carrot and stick. So the carrot has been things like the CFD mechanism or the ROC scheme that went before. So that gave an incentive to invest in projects. The stick was the thermal players were penalised for producing carbon. So in other words, there was regulatory and legal reasons for pushing heavily into this market space. When we're looking at the future, and we just need to recognise we don't necessarily always have those carrots and those sticks in other areas of this massive infrastructure change that we're trying to create that actually enables them. So I think it's very easy to create the ambition and say we should all be doing this stuff. Actually, we need to look rather hard as well at regulatory environments, policy environments, and making sure, frankly, that they are lined up well enough to incentivize properly investors who want to do this for good reason. And to come on to the previous subject matter as well, I think it's good that people make money. It won't be good if people are over-earning. That's where regulation and politics can keep looking at. But we've got to be creating industries and industry players that are benefiting around the natural changes that we're going to have to make around our infrastructure system. So a very long answer to your question, I'm afraid, Douglas, but we do need to see, I think, evolution at the policy end if we're going to properly move and address some of the challenges that certainly sit with the offshore wind sector, and then also how do we incentivize the oil and gas industry, apart from just saying you're going to fall off a cliff. How do we bring them into that space with more comfort and the optimism that it's a good thing for them to do? Maybe Colette wants to talk about the oil and gas side.
Right, come on in.
Yeah, so I think in the scenarios we've looked at, we think green hydrogen does have a huge opportunity for the UK, and we would be really keen to create a hydrogen economy by first promoting it through blue, and that potentially takes some of the pressure off the wind organisation, as Andrew's alluded to. Even now, we're going for now 40 gigabytes by 2030. The aim was sort of 70 by 2050. I think there's a big push to make that 100. What you really need if you're going to get to green hydrogen is 150 to 200 gigabytes. So we're talking like a massive growth here in wind demand. And if we can't deliver it as quickly as we want, we'll miss the opportunity to turn hydrogen into a compelling and economic fuel. We can deliver blue hydrogen by combining it with carbon sequestration. It allows us to double down on the skills of an existing sector that we already have and allow for this just transition, this ability to move people from existing jobs with high carbon output to a different future. It also allows us to provide potential services to other economies if we become really good at carbon sequestration. So we start making that a business rather than a waste management process for the country. So I think there's ways that this could be turned into an opportunity that allows the offshore wind community to build to the capacity to be able to translate into green hydrogen in the future for us. But I think the first thing is for us to decide that hydrogen is going to be one of our critical sources of energy going forward.
Colette, thank you. Just under 10 minutes to run now, so please keep the questions coming in. Next up is a question from Willie Reid from Strathclyde University. Willie, if you want to come off mute, I think you've got a question around the local content and competitiveness points on this possible future.
Can you hear me now?
Go ahead, Willie.
Okay. First of all, outstanding presentation from Martyn, and an absolutely incredible clear report. And I really think this is a great platform for action and discussion in 2021. So that's my first comment. But my question really relates to methodology, and it's great to see the ambition, fantastic ambition of the transformational case. And what I want to ask is, could you provide a bit more detail on the methodology used for the percentage of UK content? Because clearly this depends on our competitive position, it depends on different suppliers. And I really appreciated Andrew's comments on ROCs and CFDs and earlier. But this is critical relative to understanding methodology for predicting these things.
Martyn, can I bring you in first of all on that, and then we could add comments from Colette and Andrew?
Yeah, no, absolutely. Yeah, thank you very much for the question, Willie. I need to highlight that this is a piece of work that was prepared by a really strong team of colleagues from OGTC and the Catapult. So really, just have to pass on that comment. But in terms of the numbers, we did, as mentioned, use a multiplier or an in-country content value of between 40 and 75%. Starting off often at the lower end of that and working up over the 3 decades as we increase our capacity. And really, we've tried to take a look at the existing capacity today, for example, in offshore wind, the targets in the offshore wind sector deal in 2030 is an example there. And again, we've been relatively middle of the road, relatively conservative in the local content, so that there's certainly a potential upside there as well. It's maybe something we could discuss offline, Willie, just in terms of the actual detail. I'd be more than happy to connect you with the team that prepared the report. But the one thing I would stress is, as I mentioned earlier, it's similar to the approach adopted in Europe. So Germany, for example, is looking at the potential to manufacture electrolyzers and form partnerships with countries that have great renewable resource like Scotland or like North Africa. And that's where the opportunity lies, is to look at those partnership opportunities, to potentially partner with technology developers. So there's a huge onus on us to reduce the cost of electrolyzer production, both by making existing designs more efficient and potentially by looking at breakthrough innovation. So yeah, I think I would just add that we have adopted between 40 and 75% local content. There is the potential to increase that, but we do need to be aware that historically, especially I think in recent years, we maybe haven't fabricated as much as we could in the UK.
Thank you, Martyn. Does that answer the question, Willie?
Yes, and thanks for your comments and partnership, Martyn, and I'll certainly give you a call and chat about some of the detail. Thank you.
Good stuff. I love the fact, Willie, that your picture is you in action at a conference with a microphone in your hand. It's brilliant. That leads us on, I think, to Erica Askelin's question, which is again about manufacturing content. How do we actually retain some of that benefit that Colette talked about a moment ago in being a supplier of these sort of technologies? Erica, do you want to come in and explain your point here, please?
Well, I think Martyn just touched on it. Thanks very much. And I also believe that Andrew and Colette have probably discussed a lot about, perhaps potential remedies, but specifically looking at how the industrial strategy as is has seen the collapse of BIFAB and, perhaps less than stellar results for Ferguson Marine. And both of those things, of course, being based on a manufacturing heritage that is perhaps not quite what it should be, particularly in context of the ambitions of the report, which of course are amazing. If we can get there, that will be just great. But I'm just wondering, if we're worried a little bit about current damage to the reputation of our ability to deliver on these projects, particularly as Colette has pointed out that the time is now.
Thank you, Erica. We only have a few minutes left, so briefly Colette and then Andrew, and then we'll wrap up if that's okay.
I think it's one of our biggest challenges. I'm hoping that with the ambitious CCC budget that came out today as well. Reports like ours here, you know, is painting a picture of what it could be. This commentary, the CCC sort of says it's much more cost effective than they had originally planned, you know, with sort of changes that have already occurred. But actually, you know, they also refer to the need for behavioral change, and they refer to the need for for it to be fair and just. So ultimately, that all ties to we have to find a solution to the manufacturing and ensuring that these contracts can be bid and won within the country. So I don't have a perfect answer. I'm hoping that these reports and this current discussion on the budget and the green recovery will force us to come to a consistent way of managing this going forward. Because, you know, we can see the opportunity, but I don't think we're currently delivering it in the UK.
Right, thank you. Andrew, just brief remarks, please.
Yeah, sorry, Eric, I can't comment on Ferguson Marine because I don't know enough about it. It's not in my sector, but obviously BIFAB is a sad story. We would all have loved to have seen BIFAB succeed, but it's a good example of what can go wrong at the policy level. It was a business that was seen by the development community, and I can't comment on whether they're right or whether they're wrong, but it was seen as not being what they were looking for in terms of price and volume, etc., etc. And we've got policy mechanisms, as I explained with the CFD, that are originate on value for the consumer. And that's been a success for every single electricity user in the UK, where prices have come thundering down. But let's face it, at a wider policy level, it didn't address what we need to be doing in supply chain growth in the UK. I know ministers are working very, very, very hard on that. So BIFAB is a lesson for us all about what can go wrong. And we want to see those things rectified. And it's my point, which you've heard me talk about through this entire presentation. We've got to get the underlying policy aspects correct for all investors and investor confidence. Clearly, BIFAB, to answer your question, I can see in the Q&A chat here, it will damage investor confidence a little bit. It means we need to work harder at rebuilding that. My other positive I could throw into this, if I can, is the technologies are the technologies. We know what the technologies are. We're not off inventing completely brand new things in some ridiculously high risk atmosphere. I think with quite a bit of forethought, we can put all these things together and look at manufacturing efficiencies, etc., etc. But my grand call is we need the risks to be addressed. We need the policy mechanisms to be there. We need investors to be confident that they can move forwards. If we don't address those things more readily, I think the challenges of hitting net zero just increase ever further.
Thank you, Andrew. As I bring things to a close then, after what's been a very interesting and wide-ranging discussion, it's that time of the year where I can ask each of the panelists, so Martyn, then Colette, then Andrew, if you could put one thing on your Santa list to make this report achievable next year and the years to come, what would it be, Martyn, and then Colette, and then Andrew?
For me, it would be a significant investment in the technology, so a big stocking full of technology investment opportunity.
Thank you. Colette?
I like Martyn, so if we get that, I'm going to build on, our presence should go together. Clarity on the energy policy. So if we know what we're trying to deliver, and we agree that this is it, then I think it's so much easier to drive investment into the innovation where it's required, because you know what the objective is. And I think if we could create that environment, we could be super successful.
Thank you, Colette. And finally, Andrew.
Likewise, and I'm going to say this for my own business in particular, large-scale demonstration I think is a good thing. It's risky, right? But what it does do is iron out bigger risks that the market might otherwise be facing. And I think whether it's in the hydrogen space or whether it's in what else we can do across floating wind, for example, but we need to be taking some bold steps. We cannot underestimate the challenges of net zero, and just tiptoeing towards it will not be the solution.
Fantastic list. Let's hope you've all been good. let me wrap up by saying congratulations to OGTC and to ORE Catapult for a fantastic report, which I think everyone is enjoying reading and examining and taking forward. Thank you to Martyn for an excellent presentation today, to Colette and Andrew for being our panelists and taking the conversation in various directions, and particularly to all of you for joining the discussion today in what's been the last in the series for this year of Insight60. Thanks a lot.
Thank you.
Thanks, everyone. Take good care. Bye-bye.